Hello everyone. This tutorial will show you how to graph data using Microsoft Excel, as well as perform a linear regression to determine if your data resembles a straight line or has a linear relationship. So here is some mock data. I just made up a density of this material called Splando. I just made up the name. And so here you have mass and volume. Do not forget to put your units anytime you want to get your data measured, so we know that this is going to be in grams, and the volume that's measured to get the density of this material is in milliliters. So usually the way they measure density is by water displacement, so that could be one way they can get the volume of this mass. The goal here is to just graph this data, and then the second goal is to make the graph presentable or publishable. And then the third goal is to do a linear regression to see how well this data, mass per volume, resembles a straight line. So there are several ways to do this. What I'd like to do is to go, and this may be sort of a long way, but it seems to work. And by the way, this is the 2013 version of Microsoft Excel. Your version may be a lot more new, a lot more current. Or you could have a very older version of Excel. Whatever it may be, the protocol generally is the same. The layout for your Excel may be a little more different than mine. So check that out and be aware of that. So let's graph this. So the way I'll do this is I'll go under Insert. If I want to find out if points resemble a line, I'll do an XY scatter. That's the best representation. If the points, just to see, just plot X coordinate with the Y coordinate. So under Insert tab, I'll go to Charts, and this is the XY scatter. Okay, we don't see anything because we really didn't highlight any data. So if I want to highlight something on this chart, the chart area, as you can see there, I'm going to right click. So for me, I need a mouse to do all this stuff. A mouse is going to be critical for me personally. So after I right click within the chart area, I'll go to Select Data. Then I'll get this window here. I'll go to Add. The series name, let's just call it Density for now, though it really doesn't matter for purposes of this exercise, but you can just give it some random name, or you might as well could leave it blank. It has no bearing whatsoever. What do we want to plot as our x value? So remember, density is mass over volume. So we'll keep our mass as the y-axis over volume as the x-axis. Slope is usually y over x. So mass over volume, y over x would be mass on the x-axis, and mass on the y-axis, and volume on the x-axis. Mass over volume, y over x, usually that's the slope. So our x values, we'll plot it as the volume. So I clicked on, let me go back here. I clicked on this little tab here, this little button. It takes me away, and now I can highlight what I want my x-axis values to be. So I'll just, with my mouse, I'll highlight that and I'll hit enter, and those are my x values. So my y values, I'll click on this little corner box here, and then these will be my y values. And now my data is complete. All right, so you can have multiple data sets here if you want to graph more than one plot in a graph. And here's my graph. So this is not complete. I just expand this a little bit bigger. This is not complete for several reasons. Number one, we need to define our axis with labels, so that's going to be very important if you want to publish graphs in a journal or a paper. Second issue is the title. So let's make a better title of this. So to do that, we'll just click on this little title box here, and then let's just make a nice, more ornate title. So let's do density of Splando, or whatever this thing I just made up. Measured via water displacement. Okay, so just a descriptive title should be fine. And we can have a subtitle here. I think for your assessment, they want you to have a subtitle with your name. So we'll do that. So our chart title looks good. We want to label our axes. So in order to do that, let's just click on our x-axis. We'll go all the way up here to add chart element and do axis titles. Let us label the horizontal axis. The horizontal axis is our volume. Do not forget to put the units in. So the volume is going to be in mils. Let's do the same for our y-axis. So we'll click on any number in our y-axis. My version of Excel, this is the 2013 version. I'll go to Add Chart Element, back to Axis Titles, and let's do the primary vertical. And the primary vertical, highlight that with my mouse, and this will be mass. Do not forget the units. Okay, units are going to be important. So we're halfway done here. Couple of little tips I'd like to show you. If you click on any of the data points, okay, it highlights the area that's been graphed, right? So I could move this around, and if I had another array of numbers here, it will graph it. So you can move it around. It tells you what's being highlighted. Grid lines, so we can click on these little grid lines here, the horizontal grid lines. We can delete our horizontal or vertical grid lines. I'll click on the vertical and have that deleted. And then I'll do that again. I'll click on the vertical axis major grid lines, and then I'll delete that. So we have a little bit of a cleaner graph. A couple of other things I'd like to do is let's make this more presentable. Readers have a hard time if your axis labels are not big, so I just click on that text and make it a little bit bigger. Okay, so 16, that sounds right. So we can raise it to whatever size that you think is appropriate. Also, whatever font you think is appropriate. 16 to 18 is a good font size if you want to publish this in the journal. So we have our mass in the y-axis, our volume in the x-axis. Now we want to do a linear regression, which is the main point of this tutorial. Do these values fit a straight line? Well, looking at the raw data points, looks like they do, but we want some sort of assessment or measurement to see how well they lie. This mock data set lies on a straight line. So let's do a linear regression. To perform that, we'll click on any one of these points, any of one of the raw data. So we click on the raw data points, all of them get highlighted. Now on my mouse, I'm going to right click. And when I right click, you have something called Add Trend Line. So let's add trend line. You can see Microsoft Excel automatically fits the data to what it thinks is the best representation, and it automatically fits it to a line, so a linear plot. Okay, it's not going to fit it to, see, it doesn't even fit it to a log curve because the data don't fall into a log curve. So let's do this again here. So add trend line, it automatically shows it to as linear. We can do a couple of things here. We can set the intercept to 0. If you want, that can be done. Or we could just leave it as that to get the equation of the best fit line. Two other keys or boxes that I do inevitably check are the display equation and the R-square value. So let's display those two. Let's get out of here. And now we have our linear regression. The best fit line really fits nicely with our real data points. And let me make that just a little bit bigger. And here you can see the best fit line comes with the equation y equals mx plus b. So y is going to be your y-axis, the mass. M is your slope, y over x, so rise over run. So the slope of this line, this best fit line, is 0.6929. X is your volume. And then this is your y-intercept, the value when x is 0. So the y-intercept is 0.2857. So this is the equation of the best fit line. This is the equation of the linear regression line. And the R-square value is a measurement of how well the data points fit into a straight line. So R-square actually has two limits. It's a value that could range from 0 to 1. 0 implies that the points have no bearing or have no relationship whatsoever to a straight line. In that case, really, if you plot the data and the R-square is as close to 0 as possible, your data is not linear, your relationship between your variables is not linear. However, if your data is a straight line, your R-square value will gravitate closer to 1. So values that are very close to 1 as an R-square represent a linear relationship, represent data that is more of a linear type of relationship. So R-square of 0.9949 that we got from the best fit line really tells us that in this mock data set, the relationship between mass and volume really is indeed linear. So some features of this graph I want to review have a chart title, have a subtitle. You want to remove your grid lines, label with the proper units, the y-axis, label with the proper units, the x-axis, and make sure you put in your trend line to determine how well your data represents